Good morning, science students. This video tutorial is for those who are a little bit overwhelmed with the Gizmo. Wasn't my intention to make any stress for anyone. This is just too good of an activity to pass up. I know we enjoy doing them in the classroom, and sometimes it's more difficult than I think to navigate this by yourself. So in this video, I'm going to take you through in 15 minutes here. Hopefully, I'll have to watch my timer. Try and take you through all of the day one Gizmo, Trebuchet Gizmo activities. And you can just follow along with this video and hit pause whenever you want to and put in the correct answers. And hopefully you can still pick up some of the physics skills from this. When you open up your document, your assignment, you see at the top, first of all, a picture of the trebuchet, which is a fancy word for catapult. And you have some things here like the counterweight. The counterweight is what gravity pulls that down, and that makes the arm flip up and go around. There's a video here to a link that you can watch, some actual an actual trebuchet that some people bought. You can also link to the vocabulary definitions if you want to know what these words mean. A siege engine, basically siege means to surround or try to get into a castle. You might surround the castle, starve the people, not let them out, launch things at the castle. The projectile is what we're throwing, and the payload is like how heavy, or it's also the rock or the ball that we're throwing. But anyway, some of these first questions just get to some prior knowledge stuff. What challenges might you face if you attacked a castle? Well, I mean, challenges of attacking a castle, there are rock walls. Okay, it's pretty hard to bust down a rock wall. The castle is high in the air. Has tall walls. It might have a moat. People in the castle can throw things on you, etc. Okay. What are some ways to defend a castle against attack? So if you are in the castle and you're trying to defend it, you could throw things, shoot things, pour hot tar on people trying to climb up the walls, all kinds of things. Okay. It's just getting you to think about how difficult it is to get into a castle. Now, as we move along, we're going to have the Gizmo fired up here in a moment, and our job will be to first figure out what are these parts all called. Anything that has a red dot, we have to figure out the name of the part. So this part is set up so that it is a Google drawing tool, and if you just double click on it, you can open it up, and then you'll be able to put the letters in there. And one way you can see how to do this on the actual Gizmo is by taking the helps tool, dragging it, and then just hovering it above each of the red dots. It tells you what it is. But I'm just going to go ahead and show you what they are. So on this one, this little dot here, I'm going to go to my drawing tool. This little dot here on the end, that is the prong. So that's going to match up with letter G. Okay. This little red dot represents this long arm here. So that one's going to be the long arm, which is letter E. This is pointing at the rock that's in there, and that's called the payload. So the payload is B. What the payload is sitting in, this is called the sling. And the sling is F. And then this little dot here is in reference to this one. That's the dot, that's where it pivots. Okay, so that's the fulcrum. You've probably heard that word in physics classes before, 5th grade science probably. This would be representative of the short arm right here. So we have the short arm, D. And then this is the counterweight. This is the thing that actually drops down and makes the arm fling up the other way. That's the counterweight. Okay, so we got that done. Now save and close that. You're all good. Now use the video trebuchet. Just observe it for a moment. So if I'm going to do a launch, I'm just going to observe what's going on my trebuchet. And you might have to do that a couple times. Okay, a couple things that I noticed, and that's what I have to write here. What did I notice about some of the motions? Well, the counterweight moved up and then quickly down. The long arm and sling moved rapidly up in response to the counterweight. You know, I'm going to say 50 to 100 words here was probably way too much. You get the point. Like if I just check, that's probably only 60 or 40 words there, maybe even 35. That's fine. That's fine with me. If you have some basic um, observations of the motion, I'm good with that. I should probably just change this to 25. Okay. Anyway, moving right along. Now we're going to get the gizmo ready. And one thing you have to know when you're practicing these gizmos is just like we always do, look at this part here and make sure that all the dimensions are on these settings. So I'm just going to go and check 4,500 for my, and usually it's set up initially as that, but I just want to double check. 5 for a sling length. Yep, 43. Okay, 43. Yep, that's all set up just fine. Okay. It says to click the launch test, look at the results displayed at the lower right. So, okay, we're going to launch test. I wish that would say test launch. Okay, now down here it tells me my launch angle was 4.98 degrees and my initial speed was 31.05. I'm going to need that information. 4.98. The angle is approximately 4.98 degrees. Now, which trebuchet dimensions listed do you think are going to have the biggest effect on that launch angle? So when the angle of the trebuchet, so this angle here, when this starts going flying off, when the payload goes flying off, what's going to have the biggest impact on the angle, the launch angle, like when this goes, I think this thing here for sure, the prong angle. The sling length is probably going to impact that. This is just a guess at this point. And then probably the long arm. My best guesses would be prong angle, long arm, and sling length. Now, we won't really know that until we get into the testing. Okay. All right. Now you get to the experiment part. On this one, make sure your settings are all as they were in that top part. So I'm just going to go back and reset. But on this one, you are testing the sling length and trying to determine what impact does that have on the launch angle and the initial speed. So this is a variable. This is just a scientific method. We're going to move one of the variables being these, and we're going to see what's the result of that. So go back to here, and it says your sling length needs to be at 5, and that's what it's set up at right now. The sling length is 5. So I'm going to launch. And then I'm going to be looking down below at these numbers here. So 5.02 and 31.05. So 5.02 and 31.05 meters per second. I'm going to skip the labels for now. You can round these. If you want to just make that 31, that's fine too. Let's just round them. Okay, 31. Now I'm going to change my sling length to 6 and see what happens. So reset, change my sling length to 6 and launch. And then I'm going to look again at my results. 19.69 and 34. So 19.69, 19.69, and 34. Okay, now I'm going to move my sling length to 7. So reset, 7, launch. All right, and I've got 31.23 and 38. 31.23 and 38. 31.23 and 38. Now notice how I have to keep saying that in my head just to remember it. Otherwise I have to go back and forth on my tabs, which is fine too, go back and forth, but reset that to 8. Okay, launch the test. And I get 37.84 and 41. 37.84 and 41. Should start seeing a pattern here develop. Now we're going to set it one last time to 9. Okay. and I've got only 5 minutes left in this video before they cut me off because this is my free version. 41.10 and 41. So 41.10 and 41. 41.10 and 41. Now we can start looking at the data. If you look at this data, the sling length increased 1 meter, 1 meter, 1 meter, 1 meter. The launch angle went from 5 to 19 to 31 to 37, 41. I'm thinking that the launch angle is increasing as the sling length increases. The speed, 31, 34, 38, 41, kind of leveled off there at 9, didn't it? So we could even indicate that. I'm going to go back and check my facts there. Yep, 41. Okay, so basically, when you analyze this, how does increasing the sling length affect the launch angle and the initial speed? An answer could be as the sling length, I'm not going to worry about spelling here, increased, the launch angle also increased, and so did the initial speed. If you want to add that little bit in there, the initial speed stopped increasing at a sling length of 8 meters. And this is just scientific observations. Okay, we've been doing those all year. Now you try it again, but you're going to be changing something else. You're going to be, now I'm going to just notice how my page is goofed up there. So I'm just going to push return and get it down there a little bit farther. I'm going to be looking at the prong angle now and trying to notice how does the prong angle changes affect the launch angle and the initial speed. So I'm going to go back here, but I want to be careful. I want to look at all my, I want to have a counterweight of 45, payload 160, 9, 3, 9, and sling length of 9. That's the one change we have to make. The sling length has to stay at 9. So reset that. And then all this other stuff is good, but my prong angle starts at 0, okay? Because it says right here, my prong angle is 0. So I'm gonna go back and test. Okay, and I get 72.69 and 41. So 72.69 and 41 for my initial speed. Go back, oh, forgot to look, 20 degrees for a launch angle. Okay, so I reset that, not launch angle, prong angle. 20 degrees, launch it. Okay, I get 57.80 and 42. So 57.80 and 42. I'm just rounding that last number. I need to change my prong angle to 40. Prong angle to 40. Okay, launch it. I'm running out of time. Okay, and I get 41 and 41. So basically 41 and 41. I could see something happening here. I'm going to quickly change it to 60. Okay, launch. I have 21, or I'm going to 2170 and 41. 2170 and 41. And then I'm going to go to 80 degrees. And launch. And I get 1.76 and 41. So 1.76 and 41. Now, if you take a look at the data, as we increased the prong angle, the launch angle decreased quite a bit. The initial speed, we could say, pretty much stayed the same. So how does increasing the prong angle affect the launch angle? The launch angle increased and the initial speed stayed the same. And I'm not going to worry about spelling. Stop. I made it. 14 minutes and 45 seconds. So I know that was just me doing it, but it took me 15 minutes to do day 1 lesson. You can use this video and follow what I did, and you should be golden. All right. Thank you.